Video we shall try to understand demodulation, where modulation is the process of changing the characteristics of the carrier wave according to the instantaneous values of the modulating signal. Demodulation is the process of recovering the original signal or original information signal from the modulated signal. Eliminating the carrier signal is called as demodulation. Just for instance, for understanding purpose, we shall consider the diagram given here. Okay, so in this diagram, we are able to observe two things, right? So the modulating signal and the carrier signal, and this is an AM wave. Okay, this is a AM wave. What do you mean by AM wave? Amplitude modulated wave. Okay, the amplitude modulated wave consists of modulating signal and it consists of carrier signal. Both put together it becomes amplitude modulated wave. In the process of demodulation, we recover the modulating signal, we discard the carrier signal from the amplitude modulated signal. Okay, I repeat, we recover the modulating signal from the modulated signal, discarding or removing or neglecting the carrier signal. Okay, so this process of recovering the modulating signal from the modulated signal, leaving the carrier signal, is what we call it as demodulation. Okay, okay. So then we go down to the slide again. Here that is what he says here. So you can just concentrate. Like demodulation is the process of recovering the original information signal from the modulated signal, eliminating or discarding the carrier signal. This process is what we call it as demodulation. So next we go to the circuit which performs the demodulation, is what we call it as amplitude modulation diode detector circuit. Amplitude modulation or amplitude modulated diode detector circuit. So here we have input, okay, and this is isolation transformer or 1:1 transformer. So input is applied at the input of the circuit, and the signals goes to the amplitude modulated signal is applied at the input of the circuit. The signal goes to the transformer, which is 1:1 transformer as shown in the picture, and then those signals go to the diode. What happens in the diode? As we already know, diode conducts only during positive half cycle, because diode conducts only during the forward bias condition. During negative bias, diode does not conduct. Diode does not conduct, and that is why, okay, diode will not produce any negative half cycles. It produces only positive half cycles. So then these positive half cycles are made to pass through the resistor and capacitor circuit. The resistor and capacitor circuit will reform the or recover the original modulating signal. Okay, this is what happens. So let us just go through the answer. What he says here, the amplitude modulated wave is applied, the amplitude modulated signal is applied at the input of the circuit, okay, as I already told you. Okay, then what happens, the diode conducts only during the positive half cycle. The diode conducts only during the positive half cycles. Because of that, we will have these positive pulses which we are able to observe. Okay, current pulses through diode D1. Okay, so only positive half cycles are available at the end of the diode or at the completion of the circuit of diode. So then what happens, the RF and DC component, the RF and DC component are removed by the proper capacitor. Okay, RF and I mean radio frequency and DC component in the audio frequency is removed by the process signal appears at the output. What do you mean by the audio frequency signal appears at the output? AF signal is the modulating signal recovered from the modulated signal and discarding the RF. What do you mean by RF? Radio frequency signal, which is used as carrier signal. Okay, by discarding the carrier we recover the modulating signal. Which is modulating signal here? Amplitude AF, audio frequency signal, is the modulating signal which is recovered from the modulated signal, discarding the carrier signal is what we call it as demodulation, done by a demodulator circuit as shown in the picture. Okay, this is what the demodulator circuit.